In this episode, we're gonna introduce the conditions and the if, elif, and else blocks. Let's get started. In real life, you sometimes need to compare two things in order to take a decision. That's the same for Pyto. It uses conditions for comparing one or multiple variables of same type and then execute an action. And yes, it has to be of the same type, because like in real life, you can compare apple with oranges. We have three different and complementary blocks to deal with conditions in Python: the if block, the Alif block, and the else block. You can see that as a train where if is the locomotive, else the caboose, the last wagon, and between countless Alif blocks, which are the wagons. Even if those three blocks look similar, we'll see that there is small differences. Let's start with the if block. The if block always comes first and is the only essential condition block. An if block is built by using the if keyword. We then write the condition, which could be a comparison between two numbers, a combination of number and variable, or two variables, separated by a relational operator. And finally, add the colon character. On the next line, we're gonna create the inside block that Pyto will access if the condition is true. As this block is inside the if condition, don't forget the indent, or it will throw an error. Let's zoom a little bit closer. As you can see, a strange machine that kinda looks like a scale will allow Pyto to compare two values. If the result of the comparison is the same as the condition that we set, true is displayed and Pyto can access the inside block and execute the action. After Pyto has entered and executed what's inside the block, it will exit by taking the pole. In the case where the result is not equivalent to the set condition, let's change the first value to see it. In this case, 53 is more than 9, so A is greater than B. The scale is displaying false. The exit door open and Pyto continues his way. It's as simple as that. Let's take a simple example. Let's say we have two variables, A with the value of 6 and B with the value of 9. We want to test if A is less than B. So let's write it. If A inferior sign B colon, go to the line, don't forget the indent, and we're gonna print A is less than B. Let's run it. Pyto will take in his memory the first variable and will do the same with the second one. He then enters the if block, go next to the scale and introduce each value in the assigned basket. We can see that 9 is heavier than 6, so A is less than B. As the result is the same as the condition that we've set, the scale is displaying true. Pyto can access the printing block and it will print A is less than B. Pyto can now shortcut the if block by taking the pole. Now, let's say we want to test if A is greater than B. We can write it in two different ways. We can do it just by changing the condition sign, if A superior to B, or you can write if B inferior to A. Both are the same. And we're gonna ask Pyto to print A is greater than B if the condition is true. Let's run it. Pyto is doing exactly the same actions as in the first example and go next to the scale. If we take a look at the scale, we see that A is still less than B, but in that case, the condition that we set and the result are different, so the scale is displaying false. Pyto can't access the print block. The exit door open and he will continue his way. Nothing is printed to the console. For now, we have used the inferior and superior signs, which are called relational operators. But there is more, so let's do a quick overview. In this tab, you can see all the relational operators available in Python. We have equals, which is written with a double equal to avoid confusion with variable declaration. Not equal, which is a combination of exclamation point and equal. Less than or greater than, that we've already seen with the inferior and superior symbol. And you can also combine those superior and inferior symbols with equal, which means less than or equal or greater than or equal. Let's go back to our example. So, depending on what we want to test or compare, we can use whatever combination of variables and operators. We tested one condition, but what if we want to test another one if the first is not true? Let's introduce the Alif block. The Alif block is basically the same as the if block. To build an Alif block, you just have to type the Alif keyword. We then write the condition, let's say A is greater than B, and finally add the colon character. On the next line, after the indent, we're gonna create the inside block that Pyto will access if the condition is true. If we zoom a little bit closer, we can see that it has a scale to compare values, and if condition is true, Pyto can access the inside block. It will execute what's inside and take the exit. If the condition is false, Pyto will continue its path. Elif is Python's way of saying, if the previous condition were not true, then try this condition. That's why it's always attached to an if block. As long as you have the first if block, you can put as many Elif blocks as you want. It only depends on the number of conditions you want to test. Let's put the Elif block into practice. We're gonna take the previous example and change the value of both variables to 23. After the first print block, we're gonna go to the line, and at the same level of the if block, we're gonna create an Alif block with the condition A equals B. Don't forget the double equal. Colon, go to the line, and if the condition is true, we will ask Pyto to print A equals B. Let's run it. In this example, the first condition is not true, so Pyto continues its path to the next block, the Alif block, and tests the second condition. In that case, A is equal to B, so the condition is true, and Pyto can access the print block and then print A equals B. Pyto can now exit the Alif block by taking the pole. What if we want to add another condition? It's easy, you just have to add another Alif block. So, after the last print block, we're gonna create another Alif block with the condition A is different from B, colon, go to the line, indent, and we're gonna create a print block with the value A not equals B. Like in the previous example, Pyto will go to the first condition. The answer is false, so he'll continue his way to the Alif block. The answer is true, so Pyto can go into the printing block and it will print A equals B. Now, it will shortcut the last Elif block by taking the pole, because as soon as a condition is true, Pyto exits and it doesn't have to travel across the remaining of the condition blocks. Let's change one of the variable value, a, for example, that we're gonna set to 34, to see if the result is the same. Let's run it. So, Pyto will access the first if block. It's gonna check if a is inferior to b, which is not the case. So it will go to the next block, the Alif block. Now, it's gonna check if 34 is equal to 23, which is still false. It will go to the next block, the Alif block. And this time, the result is true, because 34 is greater than 23, so it's not equal. Pyto can access the print block and print a not equals b. Now it can exit the whole block by taking the pole. From the previous example, let's say we want to print something if a is superior to b. We saw from the first block that a is not inferior to b, and from the second block that a not equal b. So, by deduction, the only possibility remaining is that a is superior to b. So, instead of creating another Elif block with the a superior to b condition, we can simply use an else block. The else block is a simple block that catches anything which isn't caught by the preceding conditions. In other words, if none of the previous conditions were true and you still want Pyto to execute an action, you definitely have to use an else block. Pyto will be forced to pass through and execute what's inside. The else block is built by writing the else keyword, and because it doesn't have any condition to test, it's directly followed by a colon. On the next line, after an indent, you can add any block you want. As soon as Pyto enters an else block, he accesses directly the inside block and executes what's inside. Once finished, he can exit the whole condition block by taking the pole. That's the only way out. The else block is either attached to an if or an Elif block and is always the closing block. Let's illustrate that with an example. We're gonna take the last example and replace the last Elif block by an else block. On the same level as the last Elif block, else, colon, and to the next line, after the indent, we're gonna ask Pyto to print a is greater than b. Let's run it. As in the previous example, the first condition is false, cause 34 is greater than 23. Pyto will go to the next block. It will test if a is equal to b. And as you can see, it's also false, so it will enter the else block. Once inside, it will go directly to the print block and print a is greater than b. That's it. You just have to exit the condition block. As we saw in the else block presentation, you can also have an else block without an Elif block. For this example, we're gonna remove the remaining Elif block and see what it does. But before running the script, we have to change the print message, because if Pyto passes the first if block, it means that a is not less than b, but a can either be greater or equal to b. So we're gonna ask Pyto to print a is not less than b, cause that's the only thing we know for sure. Go Pyto! Nothing has changed for the first condition, so the comparison will be false. and Pyto will exit the if block and go to the else one, and simply print A is not less than B. It will exit then. Until now, we tested only one condition per block, but you can also test two or multiple conditions at the same time by using logical operators. In short, logical operators are used to combine conditional scales. Let's start with the AND operator. With the AND keyword, you can add as many conditions as you want. Pyto will test each one and access the inside block only if all conditions are true. If at least one of the conditions is false, Pyto will exit and continue to the next block. We're gonna take a simple example to illustrate that. We're gonna create three variables, A with a value of 200, B with a value of 33, and C with a value of 500. Let's say we want to test if A is greater than B and if C is greater than A. So we write if A superior sign B and C superior sign A colon, and on the next line, after the indent, print, open the bracket, both conditions are true. Let's run it. Pyto will memorize each variable, enter the if block, and go next to the first scale. It will introduce each value in the baskets and check the result. The first scale indicates true, so it will move to the next one and do the same steps. As we can see, the second scale also indicates true, so as both results are true, Pyto can access the inside block, and it will print both conditions are true. Pyto can now exit the Alif block by taking the pole. Let's change the value of A, for example, to see if it prints the same result. So A equals 9. Let's run it. Let's go directly to the first scale to see if there is a change. This time, A is inferior to B, so the first scale displays false. It will go to the next scale. In that case, C is still superior to A, so it's true. But as one of the conditions is false, Pyto can't access the inside block. It will exit by taking the door. Now, let's say we want Pyto to access the inside block and execute something if one of the conditions is true. We're gonna need the OR operator. As with the AND keyword, the OR keyword allows you to add as many conditions as you want. The only difference is that Pyto will access the inside block if at least one of the conditions is true. However, if all scales display false, Pyto will exit and continue to the next block. So, from the previous example, let's replace the AND keyword by an OR. It means that if A is greater than B, or if C is greater than A, Pyto will have access to the inside block. So, we need to change the print message to at least one of the conditions is true. Let's run it. Pyto will memorize the variables, go to the first scale and enter the values. As we previously saw, the first condition is not true. Pyto will do the same with the second scale, and this one displayed true. As at least one of the scale is displaying true, the OR keyword means that Pyto can access the inside block. The only remaining things to do is print at least one of the conditions is true and exit the condition block. Here is a quick reminder tab with the logical operator that we've seen and more. Don't hesitate to pause the video if you want to take your time. That's it for this episode. As usual, don't hesitate to create your own conditions, modify variables and relational operators, and change the order to see the outcome. See ya in the next episode.